Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the inverse trigonometric functions. In the last video we talked about the definition of the 6 trig functions and what they meant, as well as how we use our calculator to find them for specific angles. And in this video, we're going to take a look at finding the inverse trig functions. So what we did before when we were finding trig functions, we knew the angle, we were finding the ratio of certain sides. When we're finding inverse trig functions, we actually are given the ratio and we're finding the angle. So we're doing the opposite. So here we're finding the angle when the ratio, which is the trig function, is known. So when you're trying to find the angle, when you know the ratio, you're going to use the inverse sine function or cosine function or tangent function, depending on which inverse trig function you're dealing with. And the notation for that inverse trig function is the trig function with the exponent -1. In the last video, I mentioned that when you see a function that has a -1 exponent, it does not mean 1 over that function. It means the inverse, which is something very different. So you will see on your calculator above each of your main trig functions, the inverse will be sine to the -1, cos to the -1, tan to the -1. They do not mean 1 over sine, 1 over cos, or 1 over tan. Just understand that. So the way that we use that is if, for example, I said to you, the sine of some angle is equal to 0.5, what's the angle? So in order to find the angle, I'm going to take the inverse of the sine function, or the inverse, and that notation looks like that. So on my calculator, I would just use the inverse of the sine function, which is sine to the -1, and I should get an angle of 30 degrees. So try that with your calculator and see if you get that same result. Again, you want to make sure your calculator is in degree mode, which should be the default mode for angles. If you happen to be in radian or gradian mode, you're going to have some issues. So just learn on your calculator how you get it back to degrees or to degree mode. Let's take a look at some more examples of using these inverse trig functions. I think it's important when we are working with these to spend the time in writing out and isolating your angle. It's especially important when we're working with the reciprocal inverse trig functions. So it can get really messy and very confusing. So I know it takes another few seconds to write it out, but I think it really helps you understand the concept and helps you do it correctly on your calculator. So if I was told the sine of some angle is 0.78, I'm going to say that theta will equal the inverse sine of that ratio, 0.78, and then I would punch that into my calculator, and I would get 51.3 degrees. So I invite you to do the same with your calculator. Make sure that you are using your inverse sine function correctly. We'll do the same thing here. Cos of some angle, which I've called alpha, is equal to 0.29. So alpha will equal the inverse cos of 0.29. And if you punch that into your calculator, you should get an angle of 73.1 degrees. And you can always check these by then finding the cos of that and making sure that it's equal to that ratio. So again, try it on your calculator. Our third example, tangent of some angle I called A is equal to 1.4. Therefore, A will equal the inverse tan of 1.54. When you punch that into your calculator, you should get an angle of 57 degrees. Try these with the main trig functions first, because we're going to move on to the reciprocal trig functions, and it gets a little crazier with those. So get confident and comfortable with these, and then let's take a look at the reciprocal functions. When you're doing questions that involve the reciprocal trig functions, it's probably a good idea to have this reference handy. Remember that cosecant of an angle is the reciprocal of the sine function. Secant of an angle is the reciprocal of the cosine of that function. And cotangent is the reciprocal of the tangent function. So know those, because we're going to use those when we're finding the inverse trig functions with our reciprocal functions. So in our first example with a reciprocal function, we have cosecant of some angle that we're calling b equals 1.34. We do not have a cosecant to the -1 on our calculator, just like we do not have a cosecant function on our calculator, which I talked about in the last video. So what we want to do is think of our reciprocal functions in terms of the main functions, the three main trig functions: sine, cosine, and tangent. And it might seem like a lot of steps that I'm going to go through to get my result, but it's very important for you to have an understanding of what it is you're being told and what it is you're finding. And I see students that don't take the time to write these steps really don't understand, especially when we also get into other ways of measuring angles like radians. So you want to have a good grasp of this. So I'm going to take the time to go through the steps, and I think that you'll make far fewer mistakes if you do it the way I'm going to show you. So we don't have cosecant function or inverse cosecant function on our calculator, so I'm going to think in terms of sine. Cosecant is the reciprocal of the sine function. Therefore, the reciprocal of this ratio will equal the sine function. So if cosecant of an angle is equal to that, the sine of that same angle will equal the reciprocal of this. Now that I've got it in terms of sine, now I know what to do because I did it in the last examples. I'm going to isolate b by taking the inverse sine function of this ratio. And to get the result, there's a number of ways you can go about it with your calculator. It depends whether your calculator is a DAL, which I won't explain, but you're just going to have to play around with your calculator to see if you put your inverse sine function in first and then the quantity. Some of you'll have to put the ratio in first and then press your inverse sine function. So some of you are going to find this reciprocal first and then find the inverse sine, or some of you are going to be able to type it in exactly as you see it. So inverse sine, but just be careful with your brackets. Bracket 1 divided by 1.34, end of bracket. And some of you may choose to use the reciprocal key instead of writing 1 divided by 1.34. So there's a number of ways you can approach it, but I think you need to see it this way first so that you know the correct order and the correct functions to press on your calculator. Whatever method you do with your calculator, you should get a result of 48.3 degrees. So try it on yours, make sure that you know how to work with the reciprocal functions and the inverse of those reciprocal functions. All right, let's take a look at the next example. Very similar, except this time we're working with secant, and we need to know that secant is the reciprocal of the cosine function. So instead of working with secant, I want to switch it to cosine. So therefore, the cosine of my angle, which I'm calling beta, will be the reciprocal of this ratio. Whenever we're dealing with the reciprocal of values, we're always talking about the reciprocal of the ratios. You never take the reciprocal of angles. All right, now we want to find beta, so we can do that. Beta is going to be equal to the inverse cos of 1 over 2.75. And again, familiarize yourself with how you do it on your calculator. You should get a result of 68.7 degrees. So try that. And like I said, take your time to do those steps so that you're really clear on what exactly you're entering into your calculator. Let's do one more example, and let's work with cotangent for our last example. We'll take a look at cotangent. We know that cotangent of some angle, which I call theta, is equal to 0.4. We want to find the angle. We do not have the inverse of cotangent on our calculator, so we're going to go to its reciprocal function. We know that cotangent is the reciprocal of tangent, so therefore the tangent of theta will be the reciprocal of 0.4. Then we can isolate theta by taking the inverse tangent function of this value. When you do that, you should get an angle of 68.2 degrees. Try it on your calculator to make sure that you do. So there's a potential for error, a lot of potential for error with these questions. I can't emphasize enough how important it is for you to practice them. Practice your finding your trig functions when you know the angle, which we did in the last video. Practice finding the inverse trig functions. In other words, practice finding the angle when you know the ratio. And don't shy away from your reciprocal trig functions. I know it's more steps, it's more work, but if you get the understanding, then it's just a matter of manipulating your calculator in the correct order. All right, practice these, get confident, and then we'll move on. In the next video, we're going to look at solving right triangles. Take care and see you then.